Good afternoon. My name is Farrel. I'm from class XIPA B. I will be presenting about Newton's laws of motion. Sir Isaac Newton, PRS, was an English mathematician, physicist, astronomer, theologian, and author who is widely recognized as one of the greatest mathematicians and most influential scientists of all time, and as a key figure in this scientific revolution. He was born on January 4, 1643, Woolstopper Manor House, United Kingdom, and died at March 31, 1727, Kensington, London, United Kingdom. Well, today I will be explaining about Newton's first law. Object in motion tend to stay in motion, and object at rest tends to stay at rest unless acted upon by an unbalanced force. Newton's second law, force equals mass times acceleration, and Newton's third law, for every action there's an equal and opposite reaction. Newton's first law. Objects in motion tend to stay in motion, and objects in rest tend to stay at rest unless acted upon by an unbalanced force. What does this mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. What is meant by an unbalanced force? If the force on an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. If they are not equal and opposite, then the force are unbalanced and the motion of the object changes. Examples of law of inertia in real life is a soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. Two teams are playing tug of war. They are both exerting equal force on the rope in opposite directions. This balanced force results in no change of motion. Newton's first law is also called the law of inertia. Inertia is the tendency of an object to resist changes in its states of motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to change its motion. Okay, let's take a look at this video. Okay, because of inertia, objects including you resist changes in their motion. When the car is going 80 km per hour and is stopped by the brick wall, your body keeps moving at the same speed. Okay, like even though the car is stopped by a brick wall, your body keeps moving at 80 km per hour. This is what the law of inertia says. More example in real life. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a large force to change their motion. Once they are moving, it takes a large force to stop them. On your way to school, a bug flies into your windshield. Since the bug is so small, it has a very little inertia and exerts a very small force on your car. So small that you don't even feel it. Question: if objects in motion tend to stay in motion, why don't moving objects keep moving forever? The answer is, things don't keep moving forever because there's almost always an unbalanced force acting upon it. A book sliding across a table slows down and stops because of the force of friction. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. But what if there is no unbalanced force, okay? Let's just say that there's no force of friction, there's no force of gravity. Can that thing really happen? Well, in outer space, away from gravity and any sources of friction, a rocket ship launched with a certain speed and direction would keep going in that same direction and at the same speed forever. Okay? Why, you may ask? Because there's no unbalanced force. There's no other force making it unbalanced. Okay. Newton's second law: force equals mass times acceleration. F equals ma. Acceleration, a measurement of how quickly an object is changing speed. What does F equals ma means? Force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine we make the ball twice as big, double the mass, but keep the acceleration constant. F equals ma says that this new ball has twice the force of the old ball. Now imagine the original ball moving at twice the original acceleration. F equals ma says that the ball will again have twice the force of the ball at the original acceleration. What does F equals ma says? F equals ma basically means that the force of an object comes from its mass and its acceleration. If you double the mass, you double the force. If you double the acceleration, you then double the force. Doubling the mass and the acceleration quadruples the force. Okay? So what if you decrease the mass by half? How much force would the object have now? Okay, examples in real life. Something's very massive, high mass, thus changing speed very slowly. Low acceleration, like a glacier, can still have great force. And something very small, low mass, that's changing speed very quickly, high acceleration, like a bullet, can still have a great force. Something very small, changing speed very slowly, will have a very weak force. Newton's third law: for every action, there's an equal and opposite reaction. What does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. There's a balanced force acting on you. Gravity pulling down, your seat pushing up. Think about it. What happens if you are standing on a skateboard or slippery fall and push against a wall? You slide in the opposite direction away from the wall. Because you push on the wall, but the wall push back on you with equal and opposite force. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe hurts. Now we're going to try to solve different kinds of problems regarding Newton's law of motion. Our first question is, what force must act on a 50 kilogram mass to give it an acceleration of 0.30 meter per second squared? To solve it, we use the same formula as before, which is F equals mass times acceleration, which the mass is 50 kilograms and acceleration is 0.30 meter per second squared. We were told to find the force that must act on the 50 kilogram mass, so we need to find the F. So just multiply the 50 and the 0.30, you will get 15 kilogram meter per second squared, which is 15 newtons. Our second problem, if a baseball is thrown at a 150 meter per second squared and its mass is 0.50 kilogram, what force is necessary to change its direction? Okay, again, we use the same formula, which is F equals ma. First of all, we determine what is given by the question. We were given the acceleration, which is 150 meter per second squared, and its mass, which is 0.50 kilogram. We were told to find the force that is necessary to change its direction. We again use the same formula, F equals ma, which the mass is 0.50 kilogram and the acceleration is 150 meter per second squared. When you multiply it, you'll find 75 kilogram meter per second squared, which is 75 newton. Okay, the third question is, Sophia, whose mass is 52 kilogram, experienced a net force of 1,800 newton at the bottom of a roller coaster loop during her school's physics field trip to the local amusement park. Determine Sophia's acceleration at this location. Okay, we were told to find the acceleration. First of all, we need to find what is given to us from the question itself, which is Sophia's mass, which is 52 kilograms, the net force, which is 1,800 newton, and we're told to find the acceleration of Sophia. Okay, again, we use the same formula as before, which is F equals mass times acceleration. This formula is used when solving several questions regarding law of motion. We were told to find the acceleration, so we will switch places between the A and the F, which will give us acceleration equals force divided by mass. Then we put out the pieces together, which is the force, which is 1,800 newton, over the mass, which is 52 kilograms. Then we get 34.6. We round the answer, and we will get 35 meter per second squared. That's it, my presentation regarding law of motions. Thank you, and goodbye.